Welcome to my Skylake X overclocking tutorial. Recently I've had some people in my YouTube comments asking me, hey, how do I overclock, or what are some specifics about overclocking on Skylake X? What do I set this thing to, or this setting? So I kind of wanted to give a basic tutorial on how to overclock on Skylake X. Not going to go super in depth with some of the different more advanced topics, but I really just wanted to get something out there to help people get started. First off, I wanted to go over a couple programs that I'm going to use while stress testing, checking some thermals, some other, what you would say, some other, statistic related things, as well as, some performance monitoring, so we can actually see that your overclock is, doing something. One of the common things with overclocking that some people may not realize is that even though you might be turning your frequency up, you could see that frequency, but your performance could actually not be going up due to, a whole host of reasons. So anyways, first program that I'm going to use is AIDA64. So you can download this. There's definitely a 30-day free trial. I think there might be a trial that you can use for longer than that if that has ads or something along that. I'm not 100% sure on that, but I'll leave a description or a link to this program in the description of this video. As well as I'm using Intel Extreme Tuning Utility, which is a free utility that you can get from Intel. The reason that I am using this is mainly due to the fact that for some reason AIDA64 at this exact moment of this video doesn't report voltages correctly. So for example, you can see that it's saying my voltage is 1.82 or 1.872, which is incorrect. My voltage is actually 1.275, which you can see over here in the Intel Extreme Tuning Utility. So the difference is that, yeah, the Intel Extreme Tuning Utility happens to report your voltages correctly. So, so that's why I'm using that in combination with AIDA64. Otherwise, you could probably just use AIDA64 for that. But then also I'm using Cinebench R15. The reason I'm using Cinebench R15 is that's a really easy program that, first of all, it stresses your CPU pretty hard, which is good. So you can kind of use it a little bit for at least short-term stress testing. But then on top of that, the nice thing is we can use this to validate that our overclock is actually increasing. So, maybe we'll dial in 4.0 and then we'll dial in 4.4. So when we jump those, we should see some performance increase. So we can use a program like this to, validate that. So anyways, so the first step after installing, first step is to install these programs. Then after you install these programs, the next step is to restart your computer. Once you restart, you want to make sure that you jump into your motherboard's BIOS. So I'm using an ASUS board to do this on. So I need to hit the delete key. Most likely it's usually the delete key, or it'll be, let's see here, it could be the delete key, maybe I think F10 or F2. So it looks like F2 for me. But usually there'll be some message on the screen telling you what to do to get into your BIOS. So I'm just mashing this key real quick. As you can hear, I'm mashing it, mashing it, mashing it, mashing it. Okay, cool. So now I'm in the BIOS. So once in the BIOS, usually most BIOS will have basic mode and then an advanced mode. So we want to jump over to the advanced mode just because that's where we'll need to go to, access things like changing the voltage, changing the frequency multiplier, stuff like that. So first thing I want to do is I want to figure out where all these settings are. So most likely, so I had some stuff already dialed in here. So I'm going to just turn these, effectively I'm just going to reset everything back to auto. Let's see here, auto. And voltage down here, I think there's auto. Okay, so what you see now is probably going to be pretty close to what the defaults would be for you and your Skylake X processor. So for me on this ASUS board, so I have a 7800X. So for me, it actually comes already tuned in to 4 gigahertz. So technically, that's a little bit of an overclock because it's running on all cores, where I think by default it only runs on 1 or something along those lines, but either way, not important for right now. So there's a couple different settings here in the BIOS that I want to point out, as these are the things that we're going to really care about. So first thing here is the CPU core ratio, okay? So this is multiplying according to what our base clock is. So that's this over here. So our base clock by default is 100 megahertz. So whatever the ratio is set to, that is the frequency or your target frequency that your CPU is going to try to run at. So for example, we have 100 megahertz on our base clock and we have a ratio of 35. So therefore we're getting 3,500 megahertz or 3.5 gigahertz. So most Skylake X processors are going to run somewhere with adequate cooling. Obviously, everything's down to adequate cooling. But with adequate cooling, you should be able to run an overclock somewhere between 4.4 and 4.8. That's what I've seen, all the reviewers. Me personally, I've experienced that. It seems like that's kind of the standard. You're going to hit somewhere in there. 95% of the processors are going to be somewhere in there. Then, that top 1% maybe can hit 5 gigahertz. And then there's going to be some that can't even hit 4.4, but it's probably going to be really, really rare to be in that case. So with that being said, I think, first thing you could do is you can just come in here and you can change this to 44. So what that's going to do is that's going to change our ratio to 44 times 100 and give us a 4.4 gigahertz overclock. So in my opinion, that's a super safe thing. Come in, set. Almost every processor should be able to run that. At this point, we can also keep our AVX and AVX 512 instruction core ratio negative offset to auto. So effectively what these are going to do is AVX is an instruction set that's built into the Skylake X processors that effectively allow certain types of calculations to be done more efficiently because you can do more of them in parallel at a time. So on another processor, maybe you have to, do this calculation over 2 instructions. Well, on this processor, you can do it all at once. But with anything that's requiring more performance, you're also then most likely going to be requiring more power, therefore more cooling. So we'll get to this later, but this just allows us to say, hey, when that type of instruction is coming in, let's actually clock our processor at a different multiplier. So anyways, so after setting 4.4 here, next thing we want to target is down here is our CPU core voltage. So again, this is effectively, we're going to tell our processor, if we switch this to manual mode, that we want it to run at this frequency. So I think a safe, that's not a period, very safe, 1.20, a very safe manual voltage to try at 4.4 on Skylake X is 1.2. 1.2, almost every processor should be able to do this, 1.2 or 4.4. Some processors might be able to do it a little bit less voltage, and some might require a little bit more voltage, but it really just kind of depends on your processor, but 99% should be able to hit this mark. So I think, this is kind of our first come in, let's do something. Let's go ahead and set it to this and let's try to reset. So we'll go back over to exit, we'll hit save changes and reset. Nice thing about our, let's see here, our ASUS motherboard is it actually tells us, hey, what are the things that we changed? So you can see what my settings were before and stuff, but at this point you just want to kind of verify that you have your voltage set to 1.2, you have your core ratio set to 44, and then your AVX set to auto. And then at that point we'll hit OK. So now that I'm back in Windows, I opened up Intel Extreme Tuning Utility, IDA64, and Cinebench R15. So if you're following along, you didn't make it back into Windows, don't worry. Usually that just means it's, a failed overclock. One of the symptoms of a failed overclock is just not being able to boot into Windows. You might get in a boot loop, you might just get a blue screen. There's a lot of different things that could happen. Don't worry, hit reset, mash your delete key, get back into your BIOS and start changing things again. So most commonly, that could be a problem. Another common problem would be once you get in, your system will shut down once you're in Windows. You might see weird instability such as drivers crashing, stuff like that, programs not running, opening. If you experience any of those things, that means your overclock is not stable. At that point, to stabilize, you have 2 options. Either you can decrease your speed, your frequency, or you can increase your voltage. So with 4.4 at 1.2 volts, I was able to load into Windows no problem. So you can verify that stuff inside of the Intel Extreme Tuning Utility. So if I look over here, I can see that my max core frequency is 4.4 gigahertz. I can see that on every single core, as well as, I believe you can see that on the roll up is over here on the left. But then I can also see the voltage at which I'm running, which is 1.2. Whether you can see it on the screen or not, it's a little small, but nonetheless, it's up here in this upper right-hand corner. You can see that it says core voltage 1.2. So at this point, I know that I was at least stable enough to get into Windows, which is good. So the next step that I would do is you come over to IDA64, Tools, System Stability Tests, and at this point, you can stress your computer on, or your CPU on different tasks, and then figure out things like temperatures, and figure out whether or not it's stable, okay? So first thing that I would recommend doing is just going down this list up here in the top left, click just stress CPU. So you can click multiple things. You can click CPU stress, stress FPU, stress cache. You can click all of those at once and hit run. The issue is it's not actually going to stress all of those at the same time, or at least not the worst it could do. So the easiest of those three is CPU. So I select stress CPU, start, and what I call this is my incremental stress testing. So at this point, I'll hit start. I'll start stressing on the CPU. I'll run it for about 10 minutes. What I'm looking here is just, does it crash in 10 minutes? If it doesn't crash in 10 minutes on CPU, I'm at least to the point where I want to keep tinkering and see, can I go higher? Can I lower the voltage? A lot of different options here. So right now, at the 1.2 at 4.4, I'm able to easily hit, easily run this for 10 minutes. I know that for a fact. Also, my temperatures are in the, mid 50s for the most part. So super, super easy, like not an issue at all. So to continue this stress after those 10 minutes, then I would come down and stress the FPU. So again, have that as the only thing selected. Now, stressing FPU in IDA64, what that's actually doing is it's mostly focusing on those AVX type instruction sets. What that means is while you're stressing your FPU, you are going to get the highest temperatures you will ever see, and you're going to be pulling the most power you'll ever see, and that's a really good test for stability. So you can sit and you can run that again for 10 minutes, just like I did on the CPU. Check your temperatures, make sure everything is good. Make sure that you're not, over your temperature limit, which in my opinion, 90 is safe. Okay, so try to just not be averaging over 90 degrees on any of your cores, and I consider that as safe. Now, everybody else will have their own limits. Some people may be comfortable, at 90 like me, or 90 and less. Some people might be comfortable only in the 70s. So you pick your own limit on that. But nonetheless, this will give you a good, kind of a good worst case scenario. That is the FPU test. So after doing that for 10 minutes, then what I like to do is to come over into Cinebench R15 and then do a run. Okay, so do a run of Cinebench R15, and what this is going to do is this is going to give you a score. And you could have ran this with all its stock settings if you wanted, and so use that as your baseline. But since I think most people can get to 4.4 at 1.2, I'm going to actually use this as my baseline. So again, the reason I'm doing this is I want to make sure that my performance is actually increasing. So therefore, I want to be able to have a baseline number in some type of performance benchmark like this, and then use that to make sure my number is going up. So let's see what we got here. So we got a score of 1365. Okay, so I'm going to go ahead and remember that 1365. And at this point, let's say that I ran my test for 10 minutes on FPU and CPU and IDA64, and I ran Cinebench through no problems. At this point, I'm going to see how much farther I can go. So let's go back into the BIOS. So remember, we need to restart and get back into the BIOS. Now that we're back in our BIOS, we can continue to tweak things in order to try to get to the maximum overclock that we can get. So now that we said, okay, 4.4, at least in our quick iteration here, we considered stable. So we ran it for 10 minutes on FPU, CPU, ran a benchmark, and we feel like it's stable. So the next thing you can do is you can come in and you can start tweaking the multiplier and just continually bringing it up at that same 1.2 volts until you become unstable. So that's either, IDA64 fails or Cinebench fails, or you can't boot into Windows. So I was able to get to 4.6 stable at that 1.2. I was actually able to get 4.6 at 1.2, no issues. Ran rock solid stable, no issues. But as soon as I went to 47, it would pass Cinebench and it would pass the it would pass the CPU stress test in i64 and it would pass the Cinebench, but it wouldn't pass the FPU test. No matter how much voltage I increased, it would not pass the FPU test. So what that means to me is that it means that the AVX instructions here, so that's what the FPU test is mainly testing. And usually the way you know that this AVX is what's causing your issue is that you'll start the FPU test and it'll just immediately go to a black screen and shut down or restart, like immediately. That's usually my signal that it's an AVX issue. Most commonly, the problem is it'll try to draw too much power and your motherboard can't handle it, or you don't have enough voltage and it just can't handle it. So at this point, once I went to 4.7 and realized it wasn't stable, but it was stable at 4.6, what that made me realize was that, okay, our AVX instructions then are what's holding us back. So I bumped this up to 4.7, okay, And then instead of auto here, I switched both of these to 1. Okay, so you could do a little bit more tinkering, and you could see, okay, maybe one of them you could set, maybe AVX 512 or 512 you could set to 1, and this one you could keep it auto. There's some more tinkering in here. For me, I went with the route of just keeping these in sync, okay, because I knew they both ran at 4.6, so I just effectively kept them at 4.6. Remember, whatever number here is just a subtraction of what our core count multiplier is. So I did 4.7, and I kept going in, and I was getting stability issues. So I kept getting stability issues until I hit 1.25 volts. So I ended up getting 4.7 at 1.25 with a 1 negative offset on AVX. So I came back in, that was rock solid stable. So I came back in and said, okay, how about 4.8? What can I do at 4.8? And again, remember, this can only run 4.6 based on my testing so far. Yours could be different, but mine can only run at 4.6 with these set to auto. So I dropped these down to 2 and then set me up at 4.8. So 48 minus 2, 46. So I came in, I couldn't get stable at 1.25. I ended up, oops, wrong button. I ended up having to go to 1.275. So at 1.275, I was rock solid stable at 48 and minus 2 on our 2 on our AVX offset. So at this point, okay, I tried to go to 49. Now the issue was to get 49 and 3 on here stable, it required me to push my voltage all the way up to 1.35 volts. So that was very, very, very hard for me to get stable at that point. And at that point, my temperatures were just through the roof and I couldn't sustain them. So for me, my max was about 1.3 volts was where my temperatures were comfortable. So at 1.275, at 4.8 is where I felt most comfortable in terms of temperature and stability. So once you kind of keep doing that iteration process, okay, and you feel pretty confident about your stability in terms of like the small short stability, all you want to do is you want to save those settings, you want to reset, and then you want to go back into Windows, and at this point you want to do a more long-term stable test. Long-term stable test pretty much, you know, acts similar to my short-term stable test, except I'm going to be doing things kind of longer effectively. So I'll come into IDA64 and I will stress both the CPU and the FPU for at least a couple of hours each. So maybe if it opens, what's going on here? There we go. So I'll go into the system stability tests. Oh yeah, so it said that I quit unexpectedly, not a problem. That was known. So anyways, I'll come in here and I'll stress the CPU and the FPU. So each of those individually, so just the CPU and then just the FPU for about, I don't know, a couple hours. So at least like 3 or 4 hours each. So, you know, maybe let it run overnight, maybe, you know, let it run and go out to eat, you know, whatever it may be. So the key here is you want to make sure that your temperatures are reasonable. So remember, I'm running at 4.8 gigahertz at this point, and I'm running at 1.275 volts. So when I'm just stressing the CPU, my temperatures, you know, are mid to high 60s. So super, super reasonable. No issues there at all. So that's, you know, making sure your temperatures are good, making sure that you had no throttling down here, and making sure it doesn't crash is pretty much what you're looking for from IDA64. So you just want to run them for a couple hours each, and each CPU and FPU, and make sure it's okay. Then, after you feel comfortable doing that, what I like to do is I like to come back into, come on, maybe it's going to close one of these days, but I like to go back into Cinebench, which I'm going to open up here in a second. If I can figure out what, there we go. Close that at 64. So I want to come back into Cinebench, and effectively what I want to do is I want to do some runs in Cinebench. But I don't want to just like do a run, see the score. Pretty much what I like to do is I like to sit here for about 5 minutes, and I know it's tedious, but about 5 minutes and just keep mashing this CPU button. So what that's going to do is as soon as it's done running a test, it's just going to run it again and run it again and run it again. And it's just another nice, I mean, you don't necessarily have to do it for 5 minutes, maybe do it like 10 times. But again, it's just another way to continually try to throw some more real world stress at the CPU. Also, this is a good test to see as well, to make sure your scores are going up. So if you remember when we ran at 4.4 gigahertz, our score was 1365. Well, now at 4.8 gigahertz, our score, the one we just ran was 1510. The best score I've gotten is 1525. So again, just come in here, run this a bunch of times in a row, make sure your scores are pretty consistent and higher than your original baseline scores are. And then, you know, you can say, okay, Cinebench feels pretty good and stable. Now, the last thing that I like to do, go away. The last thing that was something about a drive not being plugged in. No issues there on the overclock. So, but one of the things I like to do here then afterwards is I actually like to go to YouTube, load up a bunch of 4K videos, and just let them play. That's another kind of real world stress test. But really, I mean, the actual way to stress the test the best is to just do what you would normally do. So like, I like to go in and play a bunch of games on Steam and, you know, maybe render out some videos out of a Premiere, work in Photoshop for a little bit. And as long as you don't notice any issues, then I would consider it stable. So usually I give myself about 2 weeks to a month to say like, hey, this is super stable. And then once I haven't had any crashes or anything like that, then I'll kind of say, okay, this is stable. I feel comfortable. I'm locking in at this point. But yeah, so that's pretty much the basic overview of how I overclock my Skylake X and, you know, what I would recommend. So, but the key points here are just remember, set the multiplier, set the voltage, get stable. And as soon as you're stable at that point, up the multiplier until you're not stable anymore, and then bump the voltage, and just keep bumping the voltage until you're stable, or you go over your temperature limit. And then if all those things are good, and eventually you get to a point where you can't go stable on the FPU test, then you can try using a negative offset there to increase your multiplier even more. So anyways, that's pretty much it. If you have any questions, pop down in the video comment section and say whatever you want. I'll try to respond. Also, I'll put links to all of these programs that I use in the description of this video if you want to go download them all. And always, thanks for watching, and have a good time overclocking.